So today the topic for discussion is Newton-Raphson method. So this method is useful to find approximate root of transcendental equations and algebraic equations. That is, the algebraic equations are what? The equations of the type x cubed plus 2x square plus 3x is equal to 0 are the algebraic equations. And if the equation is of the form x into sine x plus e raised to x is equal to 0, suppose. So this is the transcendental equations. And this method is useful to find the root of the transcendental equation as well as algebraic equations. So we first derive the formula for this method, that is Newton-Raphson formula. The question on this topic is what? Obtain or derive the Newton-Raphson formula. So suppose fx is equal to 0 is the given equation. X is equal to 0 is the given equation. And let x not be its approximate root. The root of that equation fx is equal to 0. And x1 is the correct root. Suppose x1 is the correct root of the equation. And this, suppose h is the error or difference between the correct root and approximate root. That is, this, what is x1? x1 is x0 plus h. So what is h? What is h? h is x1 minus x0. Means what is x1? x1 is the correct root or exact root. And what is x0? x0 is the approximate root. So correct root minus approximate root is equal to the h, means error. So what is x1? x1 is x0 plus h. This x0 is the approximate root. So this x1 is the correct root of the equation. Therefore, we have f of x1 is equal to 0, because x1 is the correct root of the equation fx is equal to 0. Therefore, we have f of x1 is equal to 0. That is, we have f of x0 plus h is equal to 0. We have this. Okay. And we expand this by using Taylor's series or Taylor's theorem. And what is the expansion of this f of x0 plus h? Is f of x0 plus h f dash x0 plus h square by 2 factorial f double dash x0. And that's next term is what? H cube by 3 factorial f triple dash x0. This is the expansion by using the Taylor's theorem. So here we neglect these terms, this h square by 2 factorial f double dash x0 and all the remaining terms. Why? Because h is small. Absolutely, this is the error or in the correct root and approximate root, and this h is very small. Suppose it is equal to 0.1. Suppose this h is 0.1. This h is 0.1. Then what is 0.1 square? It's 0.01. What is h cube? This is 0.001. That is, this becomes, all these terms becomes smaller terms. So neglecting these terms from h square, that is second order and higher order degree terms. So after neglecting the second order and higher order terms, what we get? Has some technical problem. My Microsoft is not supporting. Yes, not supporting. So by neglecting the second and higher order terms of this h, we have this equation f of x0 plus h f dash x0 is equal to 0. That is the left side is equal to 0. And therefore the value of h is what? This term shifted to right side, then this become minus f of x0 divided by f dash x0. Okay, this is the value of h. And then x1 is what? x0 plus h. This is our first iteration. So substitute this x0 plus h. What is the x0 plus h? So here is negative sign, but there is equal to sign, equal to x0. This x0 as it is minus f of x0 divided by f dash x0. That is, we have the formula for x1 is what? x0 minus f of x0 divided by f dash x0. Similarly, if we started instead of x0 from x1, then we get x2 is equal to, similar to this, x1 minus f of x1 divided by f dash x1. Similarly, what is x3? X3 is x2 minus f of x2 divided by f dash x2. And in this fashion, if we generalize this formula, what do we get? Xn plus 1 is xn minus f of xn divided by f dash xn. And this is the, this n runs from 0, 1, 2, 3, 4, 5. That is, if you substitute n is equal to 0 in this formula, then we get x1. If we substitute n is equal to 2, then we get x2. In this fashion, we find x0, x1, x2, x3, x4, x5. Okay. So, and this is called the Newton-Raphson formula. So, next is the geometrical meaning of this Newton-Raphson formula. Here, my Microsoft point PowerPoint not supporting properly. That's why this waiting is there. Next is next slide. So this is the geometrical meaning. So what is the geometrical meaning? We take x0 is any point. Suppose this is the equation y is equal to fx. This is the curve of the equation y is equal to fx. This curve is what? The curve of y is equal to fx. And that is our given equation, fx is equal to 0. And suppose we take x0 is any point on this curve, x0, f of x0, okay? And draw the tangent to the curve at the point x0, and where it cuts the x-axis, that point is x1. So this point is what? Is the root of the equation fx is equal to 0. Okay, y is equal to fx is equal to 0. The equation root of this, where this curve cuts the x-axis at this point. Suppose this is xi point. That is, this xi is what? Is the exact root of the equation. And we take any x0 as any initial approximation. We take any point x0 on this curve, and then draw the tangent to the curve at that point. This is the tangent to the curve, and where it cuts the x-axis is the point x1. So geometrically, what is the x1? X1 is the point where the tangent to the point x0 cuts the x-axis. Similarly, again draw the tangent to the curve at point x1, and where it cuts the x-axis is the x2. That is the second approximation. So we have the second approximation, and if we observe the difference between this x0 and this xi is larger than this. The difference between xi, this point xi, and x1 is larger. Again, is larger than the point the difference between this xi and x2. That is this x2, x3, x4 goes nearest to the root of the exact root of the equation fx is equal to 0. So geometrically, this is the meaning of the Newton-Raphson method. And then we see some examples on the Newton-Raphson method. So what is the example? By Newton-Raphson method, find the root of this equation x raised to 5 plus 5x plus 1 is equal to 0, which lies between -1 and 0. So this is given in the example that root lies between these two, and we have to find the where the root lies between, in between what interval the root lies between the equation, root of this equation. Okay. So this is the algebraic equation. X raised to 5 plus 5x plus 1 is equal to 0 is the algebraic equation. So, and this is the equation of degree 5, because its power is what? Its highest power is 5. That's why this equation is of degree 5. And so this equation has total 5 roots. Total 5 roots. And we have to find just one approximate root of this equation. And so this equation has 5 roots, means some roots lies between 0 and 1, some root lies between 1 and 2, some root lies between 2 and 3. Sometimes the root lies on the left side of 0, that is like between -1 and 0. So what do we to find first? If just this is not given, that root lies between -1 and 0, this sentence is not given in the example. Suppose we are given the problem is what? By Newton-Raphson method, find root of this equation. Just this given is equal to 0. Okay. So we denote this LHS by fx and find f dash x. So derivative of x raised to 5 is what? 5x raised to 4 plus 5. Okay. Then find two numbers, two successive integers. Suppose we find two successive integers. What are the successive integers? 0 and 1. These are successive integers. 1 and 2. These are successive integers. So find two successive integers for which fx is what? Is negative and positive. For one out of that two, fx for one fx is negative and for one fx is positive. Here minus 1. They observe this minus 1 and 0. These two are the successive numbers. Okay, so two successive integers for which for minus 1, the value of f of minus 1 is what? That is substitute x is equal to minus 1. So minus 1 raised to 5 is minus 1. 5 into minus 1 is minus 5. And this plus 1, that is minus 1 plus 1, 0. And this 5 into minus 1 is minus 5. That is the f of minus 1. We can find the value of f of minus 1, substitute x is equal to minus 1. And then substitute x is equal to 0. X is equal to substitute x is equal to 0. Then we have f of 0 is 1. So for minus 1, the value of fx is negative. And for 0, the value is positive. So root lies between minus 1 and 0. This is the theorem theorem of 5.S.C. What is the theorem? Location root theorem. By using location root theorem. What is the theorem? That if the value at minus 1 is a negative value of fx, and for 0 the value is what? Positive, and therefore the root lies between minus 1 and 0. And then take any number lies between minus 1 and 0 as an initial approximation, that is x0. So what is your choice of x0? You take any number lies between minus 1 and 0. So between minus 1 and 0, there are infinitely many numbers. For example, between minus 1 and minus 1 and 0, there is 0.4, minus 0.4, minus 0.3, minus 0.5, minus 0.6, minus 0.56, minus 0.57. There are infinitely numbers lies between minus 1 and 0. So out of that numbers, take any one number as an initial approximation. So here is what? x0 is equal to minus 0.5 is the initial approximation. It's called initial approximation. And the number lies between minus 1 and 0. Okay, and then write the Newton-Raphson general formula that xi plus 1 is equal to xi plus 1 is equal to xi minus f of xi divided by f dash xi. I runs from 0, 1, 2, 3 up to infinity. Then substitute I is equal to 0. Substitute I is equal to 0. Then what do we have? 0 plus 1 is x1 is equal to x0. I substitute I is equal to 0. F dash x0, f of x0 divided by f dash x0. And substitute the values of this x0. What is x0? Is minus 0.5 minus f of minus 0.5 divided by f dash minus 0.5. Okay. And so what is f of minus 0.5? The f of minus 0.5 is what? Substitute in fx, x is equal to minus 0.5. So this is the calculation. The next step is the calculation. This is the calculation. That is substitute x is equal to minus 0.5. So 5 into minus 0.5 plus 1 divided by what is f dash? F dash minus 0.5. Substitute x is equal to minus 0.5 in this f dash x. So we have this. That 5 into minus 0.5 raised to 4 plus 5. And the calculation by using calculator, we have this answer minus 0.2118. Okay, this is a round up answer, round up to 4 decimal places. Round up the answer up to 4 decimal places. That is, and this is by using the calculator. Then the next approximation x2. So how we can find x2? Substitute I is equal to 1. Therefore, x2 is equal to x1 minus f of x1 divided by f dash x1. And again, substitute substitute f of x1. F of x1 is what? Substitute x is equal to x1, that is this value, minus 0.2118. Then this is upper is what? F of x1. This is f dash x1, and calculate this uh, all calculations by calculator. We have the answer minus 0.2. Similarly, you can find x3, x4, x5, and here is we have the final answer. What is the final answer? So after fourth iteration, suppose at the fourth iteration, what is the desired root? Minus 0.1998. So when we stop this calculation, repeating the iterations, so if we observe x3 and x4, so then if we subtracting x3 and x4, if we find the difference between x3 and x4, then it is what? It is up to 0.0001. That is, this answer is correct up to 3 decimal places. Okay, so if we have the answer, desired answer, we stop the finding roots, and this is the final root of this equation. So we can also use this method to find the root of the transcendental equation. X into sin x plus cos x is equal to 0 is again what? This is what? Transcendental equation, and we have to find the root of this equation. Again, find 2 points. Let fx is this side, left side. Its derivative is this, x into sin x. Derivative is y is u into 0, and derivative of cos x is minus sin x. So we have x into sin x is the dash x. Then I take x naught. It is the initial approximation. This is given in the example, x naught is 2.5. If it is not given, then find the two values, two successive integers for which f of x is negative and f of x is positive. And therefore, we have x1 is equal to, again formula, x naught minus f of x naught divided by f dash x naught by using the general formula of Newton-Raphson method. And then substitute the value of x naught as 2.5. Okay, and then find what we have, this f of x naught, that is, this is fx, the substitute x is equal to x naught, that is 2.5. So sine 2.5 plus cos 2.5. And similarly, f dash x naught is what? This is f dash x into cos x, so substitute x is equal to 2.5. And then find the value of sine 2.5 by using calculator. But if we are going to find value of sine 2.5, then convert the calculator to radian, because your calculator is usually in degree mode. So convert the calculator to radian mode, and then find the value of sine 2.5, cos 2.5. Okay, and substitute the values and calculate this all calculations. We get the answer 2.8469. Similarly, find x2. Again, x2 is what? x1 minus f of x1 divided by f dash x1. And similarly, find x3, x4, and if you observe the two successive values x3 and x4, exactly they are exactly same. That is, this answer is is correct up to 3 decimal places. So this is the final answer. This is 2.798 is what is the approximate root of this equation. Okay, given equations. So this is about the Newton-Raphson methods and use of the Newton-Raphson method to solve the algebraic equations and transcendental equations.